Bioline, the PCR company, proudly introduced the SensiFAST family, exceeding the limit in real-time PCR. Presentation by Dr. Steve Hawkins, Senior Global Product Manager.
Bioline, a molecular biology company, has been serving the PCR and real-time PCR communities for over 20 years now. Today I want to talk to you about SensiFAST, the latest innovation in real-time PCR. Before I start talking to you about fast PCR, I just want to mention standard PCR. A standard real-time PCR reaction takes between 70 to 95 minutes. Using fast kits, you can take that same reaction and reduce it down to 30 minutes. Why do real-time PCR faster? Well, one of the reasons for this is 70% of the real-time instruments on the market have 4 or more users. Being able to do the reactions faster overcomes this bottleneck. Secondly, faster reactions improves the workflow. You can do more reactions in a given time. And thirdly, this allows you to do faster reactions, which is good for things like diagnostics, where you need results quickly. The SensiFAST range gives increased sensitivity, higher specificity, faster results, more robust performance, and it uses an improved reverse transcriptase. This increased sensitivity is down to a unique buffer chemistry, giving excellent CT detection even with low copy targets. The higher specificity is down to an antibody-mediated hot start, resulting in no primer dimers. And you end up with much faster results without compromising reproducibility. So how did we develop SensiFAST? Well, developing a real-time PCR assay has many challenges. What we need to do is we need to increase speed without losing assay performance. With SensiFAST, we actually found a faster polymerase with higher processivity. So if you compare this to a standard polymerase, the annealing and the extension times take between 15 to 60 seconds, whereas with the SensiFAST polymerase, the annealing and the extension times only take 5 to 10 seconds. So the reaction is much faster. And you can see the difference on the results of the slide. You can see using relatively fast reaction times, what you actually see here is the SensiFAST actually working very well, whereas the standard tack performing very badly. A faster processivity allows you to combine the annealing and the extension steps. So now what we can do is we can go from a 3-step reaction where we have a denaturation, an annealing and an extension step to a 2-step reaction where we have a denaturation step and a combined annealing and extension step. We're cutting down the amount of steps from 3 to 2, and this makes the reaction faster. Engineering the polymerase is actually only half the story. With SensiFAST, we actually tested lots of different buffers, different concentrations, different pHs, different stabilizers, different enhancers, and we also incorporated Bioline's ultra-pure DNTPs to give the best possible sensitivity. And remember, an early CT value is not indicative of sensitivity. It's necessary to check whether the kit provides specific amplification at lower template concentrations as well. Why is sensitivity so important? Well, sensitivity will actually influence PCR efficiency. A low PCR efficiency will result in inaccurate real-time PCR quantification. So you can see here why it's important. You can have an early CT value, but if you have poor sensitivity, what it will do is actually result in poor efficiency. Whereas if you have a late CT value and you have good sensitivity, this will actually result in good PCR efficiency. The other thing that this actually results in is good consistency. And you can actually see results here on this slide show with the SensiFAST we have consistency not only at an individual concentration, but also when we do a serial dilution. So you can see here, you're not getting the poor sensitivity and you're not getting the poor efficiency. You're getting the same result time and time again, not only for the cyber green, but for the probe as well. This consistency not only goes for the cyber green and the probe, but also with the more difficult multiplexing. And you can see here on this slide, whether you're in this case singleplexing or fourplexing, quadrupleplexing, you're getting exactly the same CT results with the SensiFAST, unlike some of the competition. So once we had produced a really good SensiFAST mix for DNA, we then used it for the more difficult RNA, and this is the SensiFAST one-step kits. This is where you take reverse transcriptase and the polymerase, put them together in one tube, add RNA, allow the reverse transcriptase to produce the cDNA, and then to do the PCR afterwards. The other thing we did was to improve the reverse transcriptase. What we did was we found a reverse transcriptase that worked extremely well with the polymerase. Not only that, but we found a reverse transcriptase that worked very well at higher temperatures. Because of this, it means that you reduce the potential for problems with secondary structure in the RNA. So now what you can see is very good sensitivity and consistency in exactly the same way we saw with the DNA. We're seeing here with the one step with the RNA, both across a serial dilution and with the sensitivity itself in various different genes and between the cyber and the probe. And you can see also that this applies to the one-step multiplexing as well. So again, whether we're doing a singleplex or we're doing a multiplex, you see exactly the same results with the SensiFAST one-step, unlike some of our competitors. Applications of SensiFAST. SensiFAST, because it is fast, can be used for high throughput real-time PCR. It can also be used, as you saw, for low copy number detection. This makes it great for things such as microarray validation, pathogen detection, and any other reaction you wish to do. So in conclusion, you can now see why SensiFAST gives increased sensitivity. This is down to the unique buffer chemistry, giving excellent CT detection even with low copy targets. Improved reverse transcriptase allows you to work with RNA as well as the DNA. The higher specificity comes with the antibody-mediated hot start, ensuring you're not getting primer dimers, so lower yield. This results in faster reactions without compromising reproducibility for both standard and fast instruments. The future of real-time PCR is more, faster, quicker, better. SensiFAST rises to this challenge.